I want you to understand transformations. That's the reason I'm taking the time to go through the graphing on this, because you need to understand how the math works and not just memorize that this causes it to reflect, this causes it to move up and down. You want to know the why part. So the first thing we're going to look at is a vertical reflection, and that just means you have a graph, it turns over the x-axis. So we've already learned how to do the elementary function. So we've already learned how to do absolute value. That was the one that was a v. So we're going to do this table. This table, we're going to do it very fast. So if you do the absolute value of all these numbers, you're going to get 2, 1, 0, 1, 2. Okay, that's the elementary function. So what I'd like you to do on that is go ahead and plot those points. And then kind of do like a dash line, kind of like this. And then just label that y equals absolute value of x. Okay, so that's what you learned, earlier in the last section is what that graph looks like. Now, what's going to happen on this if you have a negative absolute value of x? All that's going to do is it's going to take those y values and turn them all into a negative. So what happens is this thing, and this is a good note to write to yourself, that negative, what it does is it multiplies y by -1. Okay, that's what happens, and that's why this thing reflects. So you just do this in your head. You would have -2, -1, 0, -1, -2 like that. Okay, now you want to plot those points, and then you'll just have the V shape reflected over the x-axis. Okay, so if we do that, we would have -2, -2, -1, -1, and so forth. Okay, and then that's your final function like that. So that's the graph of y equals negative absolute value of x. So what's going to happen is if you have one of the elementary functions we went over today, if you have a negative in front of it, it makes all the y values go to opposite, therefore it reflects. Does that make sense? Okay, you reflect over the x by making y opposite. It moves everything from the top to the bottom or vice versa. Okay, now when we're doing the domain, we're looking at the domain. I'm looking at the final thing, not the original thing. So the domain on that blue graph is just going to be all real numbers. Okay, what's the range on the blue graph? Where to where for y? Where to where? Negative infinity, right? To where? 0. Okay, it's everything below the x-axis. So your range would go negative infinity, 0, bracket like that. Okay, does that make sense what I did? When you get right down to it, graphing seriously is arithmetic and plotting points. And if you understand how the arithmetic goes, then you'll understand the transformation and you will remember it. Okay? When you get to calculus, you work with functions all the time, so you want to be able to, when you see a function, in your mind kind of have the idea of what's going on. So if you're a calculus student, you'd say, okay, I got a v, but it's reflected, right? You want to just know that kind of quickly. Okay, let's go to the next one. This is the same thing. I'm just generally going to do 2 examples of these today as we go through them. So we have the square root of x, all right? So what we want to do on this is really, since we're doing a square root, I probably should have been paying a little bit better attention on this. Let's just cross that out and let's do like 1, 4, 9. Okay, if you're doing a square root, pick numbers you know square roots of, so you don't have to worry about decimals. Okay, and then the first row, you want to quickly do that in your head. So you would have square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and so forth. Okay, and then just plot those points. So we have 0, 0, 1, 1, 4, 2, and 9, 3 like that. And again, use a dashed line. That's the elementary function. And just write that as y equals root x. Okay, now see, we already learned that in the previous section then. So that goes like that. Okay? All right. Now again, what is this negative going to do to all those y values? How's it going to change these things? I go to negative, right? Okay. So all those things go to opposites. So you would just have, on this, you would have -3, -2, -1, and then that still stays 0. Okay, so that's why it reflects it over the x-axis, is because it changes the y's. Okay, if you plot that out, you would have 0, 0, 1, negative 1, and so forth. Okay, so that's what the graph of the reflected over x-axis does. Okay, so we're going to kind of put each transformation together, and then after we do that, we'll kind of try to put it all together. That's kind of the challenge. Okay, what's the domain on my green graph on here? Where to where? Where to where? I'm asking.
0 to infinity.
Okay, thank you. 0 to infinity. Include the 0, infinity like that. Can you tell me what the range is, please? Negative infinity to 0. Okay, the range is the y's, so the y values start infinitely small, then they get to 0. Okay, so I want to kind of talk about domain and range as we can continue to do this. Okay, so here's what you want to kind of be able to do on this. So if I gave you any elementary function, I don't care what it is. So if I gave you f of x equals x squared, you know that's the parabola, right? And if I put a negative in this, then what does it do? The parabola does that. So it's got to be, the negative has to be in front of the function, outside and in front, because it changes the y's. Okay, usually reflections are very easy for students. They get a little harder as we go through. Any questions about what I did with the math? Because you want to understand, okay? That's your goal. Okay, don't just memorize. There's a negative there, it reflects. Okay, that's no good. Understand why. Okay. Now, next thing we're going to look at, and there's several transformations we look at. We're going to look at what we call a vertical translation, and that just means the graph is going up and down. Okay. So again, what we're going to do on this, we've got x squared minus 4. So we're just going to do the elementary function, and then we're going to see what the minus 4 does. Okay. So you basically do this in your head. You square each x that I gave you, so you would have 4, 1, 0, 1, and 4 like that. Okay, you want to get those points plotted like we did in the previous section. And then that would give you your, what we call the parabola, and that's your elementary function. All right, so we got that. All right, now here's what happens. Okay, what you're doing is you're taking the value of x squared and you're subtracting 4. So in your head, you're just doing 4 minus 4, 1 minus 4, 0 minus 4, and so forth. You want to understand why this thing is going to move the graph the way it does. So this one, on this second one, you just did your head. 4 minus 4 is 0. 4 minus 1 is 3. 0 minus, what? Hold on, teacher. Okay, you got 1 minus 4 is negative 3. And then 0 minus 4 is negative 4. 1 minus 4 is negative 3. And then 4 minus 4 is 0. So I'm taking the y value and I'm subtracting 4. Now, what is that going to cause the graph to do? If all the y values got smaller by 4, then what happens to your graph? It goes down 4, right? If all the y's get smaller, then you're going down. So when you go through and plot your result, you would have these points. So you would have negative 2, 0. Looks like you would have negative 1, negative 3, 0, negative 4, and so forth. Okay, so this one is a translation that we would say is down 4. Okay, like that. Does that make sense why it went down 4? Y got smaller, right? Okay, and again, you want to understand, okay, because if you understand stuff, you'll remember it. Okay, and the domain on this one, the green graph, is all real numbers. Okay, tell me what the range is of my green graph, where to where? Okay, starts at negative 4, lowest y is negative 4, and then we go to infinity like that. Okay, so that would be how that one goes, all right? Okay, any questions? Yeah.
Why negative 4?
Because of that, because that's in the problem. Okay, so what I'm doing is you're doing x squared, that's the elementary function, and then minus 4 just means that the result of all those is going to get smaller by 4. Okay, if I put a x minus 10 there, then what would happen? Everything would go down 10. so forth, okay? Because what's happening is all the y's are getting smaller.
Because x is squared, so anything, then.
Yeah, what you're doing, of course, is the first thing you're doing is you're squaring. Okay, and that's what that row is. And that's what the red graph is. But then you're taking the value of the x squared and you're subtracting 4. Okay, 4 minus 4 is 0. 1 minus 4 is negative 3. And then that's what causes it to get the graph to move down forward. Does that make sense? Okay, you just want to understand how the arithmetic goes on these. Okay, all right. Okay, let's do this next one here. So this one is the absolute value of x. So you want to just kind of quickly do the first row. Absolute value of all these x values is going to go positive. So that's 2, 1, 0, 1, and 2 like that. That's the v shape, that elementary function. So we want to get that plotted. And that will be, again, the elementary function. I just like to have you use a dashed line to represent that then. Okay, so that's how that goes. All right. Now, what are you going to do with that 3? How is that 3 going to affect the first row? Because it's plus 3, so what's it going to do?
Rise.
It's going to make everything go up. The y values are all going to get bigger, so in your head, you just add 3 to all of those numbers. And when you add 3 to all those numbers, then everything's going to go up. Okay, so with this one, you'd have 2 plus 3 is 5. 1 plus 3 is 4. 0 plus 3 is 3. 3 plus 1 is 4. And then 2 plus 3 is 5. Okay, so that's going to cause the graph to go up by 3 units. Okay, so if you plot your points, let's see, we'd have negative 2, 5, negative 1, 4, and so forth. Okay, so you can see every point on this just got moved up 3 units. Okay, does that make sense? That's really logical. So if you add, it goes up. If you subtract, it goes down. Either y gets bigger or it gets smaller. That's what's going on. Now let's see, the domain on this would be all real numbers. Again, you can do the absolute value of any number. And then this time the range is going to go 3 and beyond. So you would have 3 to infinity like that. Okay, so that is your second transformation. We call that a vertical shift up and down. Okay, so it'll kind of work like this. So like if you had something like a square root of x, all right? If I put a plus 2 on the outside, what does that do? Whole thing goes up 2. If I do square root of x minus 3, what happens? Whole thing goes down 3. That's it. It's the y value that changes, and that's what causes it to go up or down. That's what I want you to understand, okay? Okay, questions on that one? Okay, I'm going to kind of do the simpler ones first. Okay, this one's a little harder to explain, but it's kind of it's easy to see how it goes if you take the time to count out the values. So this is going to be a cubic function. Now what's different is I've got the x minus 2, but it's inside the function. Okay, that's why I said you're within the function, and if you're within the function, it changes how x behaves. Okay, and we'll kind of get to that in just a minute. So the first thing that we want to do is go ahead and do the cubing. You just raise all those numbers to the third power. So if you do negative 2 to the third, that gives negative 8. Negative 1 to the third is negative 1, and so forth. Okay, so that's your elementary function. You want to get that plotted. Okay, so that'll be left 2 down 8, left 1 down 1, 0, 0, 1, 1, and 2, 8. And then that's the elementary function that we learned for x cubed. Okay, now what I'm going to do on this is something different. Okay, what it's doing is it's changing the x before it cubes it. Okay, so we're just going to crunch a few of these out. So watch how I do this, and you may mainly want to write a few of these out. So what I'm going to do is I'm going to start by plugging in negative 2 into this function that we're graphing. So if you did that, you would have y equals negative 2 minus 2 to the third power. I'm just going to plug it in and calculate, and I want you to see what happens to these points. So that would be negative 4 to the third And if you needed a calculator on that, you'd get negative 64. Okay? So it's not going up or down, something else is happening on this. So you just want to one by one crunch them out. We'll start seeing a pattern here in a minute. Okay, next thing is plug in the negative 1. So you would have negative 1 minus 2 to the third. That's negative 3 to the third. So that's negative 27. Okay, like that. All right, just plug it in on these. Plug the 0 in. Okay, if you did that, you would have 0 minus 2 to the third. That would be negative 8, like that. Okay, and I'm going to do another one and kind of see if you guys see what's going on. If you have background for this, you may already know what you're doing on this. So the next one would be 1 minus 2 to the third. So that's negative 1 to the third, which is negative 1. Okay, now if you kind of look at this, what's going to happen on this is something's happening to my values. Look at this. Okay, you have a negative 8 there and you have a negative 8 there. You have a negative 1 and a negative 1 there. And then if you go on and do the next one, it's going to, what's happening to my table? That's what I want you to see. What's happening to these y values? They're kind of switching, aren't they? Okay, so it looks like the negative 8 went over 2 units to there. Okay, and what'll happen if I do the last one, if I do like 2 minus 2 to the third power, 0 to the third will give you 0. So what I want you to see is this thing moved there. Okay, so what it did is it moved everything to the right too. The whole graph is going to move over to the right too on this problem. Okay, so here's what a couple of things you want to write to yourself here. So you want to write down that this is moving to the right too, and we'll talk about why that is in just a minute. So it basically goes like this then. We're going to plot our points, the ones that will fit on the graph. And if you start plotting these points, you'll clearly see them. So I'm going to just plot them out. Don't worry about the negative 64, negative 27. They're out of range, so it doesn't matter. So I'm just going to go to 2, 0. Let's see, then I got 1, negative 1. And I got 0, negative 8. And what will happen on this graph is it'll kind of do this thing. Everything gets switched over to the right too, like that. Okay, so that's the idea. Okay. So what happens on this is this basically is all of the x values just move to the right 2 units, like that. I'm not going to worry about the transformation of the points. What you need to know is the x minus 2 causes it to go to the right 2. Now what you have to know is, see, that x minus 2 is inside the cubic. That's real important. If it's inside, it affects x values. If that's an x minus, everything goes to the right. What do you suppose would happen if that was x plus 2? It goes to the left. Okay, it's kind of backwards of what seems to make sense, but that's the way it works out. Okay, so again, you got to be, the key thing when you're learning this is the adding and subtracting is inside the function. That's what causes it to go right left. Does that make any sense? Okay, the table should show that. I think it's pretty clear to see everything is switching over 2 units. Okay, all right. And then the domain on the green graph, these are all real numbers. Anytime you have a cubic function, x and y can be anything. Okay, so that's how that goes. Okay, any questions? Okay. Okay, let's move to this next one then. All right, so we're going to do the square root. Okay, so what do I need to use for x? Where do I start? It's a square root, so where do I start? 0. I know the square root of 0, right? What else do I know? I know the square root of 1. I know the square root of 4. That's good enough. We don't need to go beyond that because we're going to run out of room on our graph anyway, okay? So what we'll do with this then is just fill this out. So you'll have square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, like that, and then that's your elementary function, okay? So that's the one that kind of does the swoosh. Okay, so it goes like this: 0, 0, 1, 1, 4, 2, and then that's your elementary function like that. Okay. Now on these, what I'm going to do is I'm just going to crunch them out. I just want you to see how everything works on here. So what I'm going to do is just kind of plug in, like I'm going to plug the 0 into square root of x plus 4. And you can do these in your head if you want to. So if you do 0 plus 4, you get square root of 4, which is equal to 2. So that thing translates to 2 like that, okay? You can plug the 1 in, okay? If you plug the 1 in, you would have square root of 1 plus 4. That's square root of 5. Square root of 5 is like, I don't know, 2 point something. I can do that on my calculator real quick. But there's something basically I want you to see on this. So if I do square root of 5, I get 2.2. So you can put in a 2.2 there if you want to, like that. If I put in a 4 in, I would have square root of 4 plus 4. That's square root of 8. And if I do square root of 8, again, I'm going to have some decimals. Okay, so that's like 2.8, like that. All right, so this is basically what I want you to kind of see on this then, is look at these y values right here. Basically, what's going to happen on this one is the y values are kind of going to be switching over a little bit. So that's a plus. So what it's going to do is everything's going to go to the left 1. Okay, it's not as easy to see based on the points I did. If you did more things on this, I think you'd be able to see that okay. So let's go ahead and just plot those 3 points, and then we should be able to kind of see how that goes then. All right. Now, one thing that we got to do on here that you also need to do is I probably should have used, I'm going to go ahead and do one more thing. I'm going to use x equals -4. Okay. And the reason I'm going to do that is if I use x equals -4, if you plug that in, you would have square root of -4 plus 4. That's square root of 0, so that's 0. Okay. So you would end up having that point like that. Now, if you plot these points, what's going to happen is you'll end up, whoa, hold on, what did I do? Did I do something? Why did I do -4? Oh, I know what I'm doing. Okay, I'm plugging into the wrong thing. Okay, this thing is supposed to be square root of x plus 4. That's why I'm confusing myself here. I meant for the function to be square root of x plus 4, not x plus 1. Okay, so scratch that out and change that. So what's going to happen then is this one, if you plot the points, if you do -4, 0, and then you could do 0, 2, and so forth, this is mainly what you want to have, is just see that that thing has moved to the left 4. Okay? Now, once you get the handle of how these things go, once you know that it's going to go left or right, then you don't have to do any number crunching. You just move your graph, say. Okay, so that's the idea. That one's kind of harder to see on my table because I didn't choose real good numbers. That's why, okay? So that's the way that goes, and then the domain is going to be where to where. Domain on the green graph is what? -4 to infinity. Range is what? 0 to infinity. Okay, like that, okay? So we'll have for our domain, we'll have this. And then for our range, we'll have, it looks like 0, whoops, we can have bracket 0 to infinity like that. Okay? Now, let me show you what I'm trying to get you to do. Okay, so if you see, let me just give you an example. Let's say we have an absolute value. Okay, you know absolute value is the V, right? Well, if I put a number inside the absolute value, that changes everything left and right. Okay, so you know how to do the V shape. What is the x minus 1 going to do? What do you think? That's right 1. How about the x plus 2? Left 2. Okay, it's backwards of what it seems to be. Well, that's the way it works. So it's a minus, it goes that way. If it's a plus, it goes to the left. Okay, that's what you need to see as a student. And the key thing is you're inside the function. You're not outside the function. Okay, is there any question about that? Okay, now let me before I go to this next page, I want to show you one other thing. Because I kind of want to summarize these things as I go. Okay, what if you had absolute value of x plus 3? What happens to the V shape? It goes up. Okay, and then the next one, what would that do? It goes down. Okay, this is super important when you're learning transformations. It all depends on where everything is. If you're inside the function with x, if you're inside, you're changing x. If you're changing x, that's what's making you go this way. If you're outside the function, outside of that absolute value, it changes y. Okay, that's what I want you to try to understand as you learn these transformations. Inside the function messes with x, outside messes with y. If you get that in your head, it'll help you. Okay? Okay, now let's go the next thing here. We got several of these transformations. We just do them one at a time, and then we try to put them all together. Okay? So on the next page, let's go ahead and do the squaring. So we're going to do the squaring function. So you can square all the x values in your head, okay? So that would be 4, 1, 0, 1, 4. And then that's the parabola. So we want to get all those things graphed. Okay, so that would be the graph of y equals x squared. That's your elementary function. Okay? Now, here's what I'm trying to get you to understand. Okay, what are you doing with that 2? You're multiplying, right? So you're going to multiply every y value by 2. That's not inside the parentheses. That 2 is not being squared, so it's changing y. So all you're going to do is double those values like that then. So if you do this in your head, you got 2 times 4 and so forth. 2 times 4 is 8. 2 times 1 is 2. This would be 1, 0, and then 2 and 8 like that. All right, when you plot those points, what's happening? It's not really moving up. Something else is happening. You know what's happening?
It's getting wider.
It's kind of this way. It's kind of getting wider this way. It's kind of stretching is what's happening. So if you plot your points, I think you'll see that pretty clearly. So you have negative 2, 8, negative 1, 1, or no, negative 1, 2, and so forth. And then you still have 0, 0. So you still have that same point. Then you have 1, 2, and then 2, 8 like that. So the graph is like this. So it's stretching it. Okay, it's not moving it up. It's like a rubber band being pulled in the y direction. It's stretching. So what we call this one is we call this a vertical stretch. Okay, so that's kind of what happens on that one. Okay, it just gets bigger in the y direction. The y's get bigger. That's why it stretches. What you want to know as a student is all this is doing is making y's bigger, therefore it's stretching. Okay, that's the idea. They get bigger, the y's get bigger, you stretch. They get smaller, you shrink. That's the idea. Okay, and let's see, this one, the domain would be all real numbers. The range would be 0 to infinity like that. All right, does the arithmetic make sense? So I'm basically doing arithmetic and plotting points on every single thing we do. Okay, that's what graphing is. Okay, you're plotting points. Okay, next one. Okay, so what's going to happen on this one is we're going to do the absolute value of x, and you want to do the first row just quickly in your head, so do the absolute value of all those numbers. So you're going to have 2, 1, 0, 1, and 2, like that. And then that's your elementary function. Okay, so I got that. All right, tell me what the 1/2 is going to do. The last problem doubled everything. What is this going to do? It's going to take half of them. So you're going to take half of all those numbers. You can do that in your head if you want to. So a half of 2, of course, is 1. Half of 1 is a half. Half of 0 is still 0. Half of 1's a half, and then half of 2 is 1 like that. Okay? So you're taking that by half, and then if you plot these points, you would have negative 2, 1, negative 1, a half, and so forth. So if you plot that out, then it's the same V shape, but it does that. Okay, so what happened to the graph? The last one stretched. What did this do? Kind of flattened it out. We call that a vertical shrink. Now you can't just say stretch or shrink, you've got to say vertical. You got to tell me which direction that's in then. So what we would call this is we would call it a vertical shrink, like that. Now what you're trying to learn on this is how do I know the difference? If you're in calculus, again, like I'm saying, you want to know what these graphs look like just by looking at them if you're in a higher math class. Okay, what is it that made this stretch and made that shrink? What do you think? That number right there has to be bigger than what? What do you think? 1. If it's bigger than 1, then these numbers get bigger. How about that number? If you want it to shrink, what does that number got to be between? Like z, it's got to be a fraction between 0 and 1. Okay, like that. So what's going to happen is the difference between the two is going to be in those numbers. So what I kind of have outlined up here for you is you have a vertical stretch if that number in front is bigger than 1, and it's a compression. A compression is a shrink. I don't remember which way our textbook says this. They may use compression, but that's if you have a fractional value. Okay, that's how that goes. All right. All right. Any questions? Okay. All right. Okay, so this one would have a domain of all real numbers. Then would have a range of 0 to infinity like that. Okay. So that's another one. Okay, we got several more of these things that we kind of look at. All right. If you forget them, you can always figure them out by just kind of crunching out the numbers. Okay. Okay, the next one's kind of weird. This one's, I think, anytime you kind of change the x value, it's a little harder, I think, to understand. So this one is what we call horizontal stretching and shrinking. So that would be the opposite of the last problem. So the last problem we did stretch things this way and shrunk this way. Well, we could take the absolute value and compress it or stretch it, okay, in the x direction. So this is going to be more in the horizontal direction. So the way to understand this is to number crunch. Okay, so we're going to do the same thing with our elementary function. You want to go ahead and get that done real quick and fast in your head. So square all the numbers. So that's 4, 1, 0, 1, 4. And get that plotted. That's the parabola. Okay, so we got that. All right, now what's going to happen is that 2x, where is the 2 this time? The 2 is inside the function. Does everybody understand what I mean by that? You're inside of the squaring, the function squaring. So anytime you're doing something inside of the function, it affects x values. It doesn't affect y values. So we're going to crunch this one out just kind of one at a time. So I'm just going to plug in, just have you plug in the x's into the function we're doing, and that's the best way to see this anyway. So I'm going to do 2 times negative 2 to the second, then I'm going to do 2 times negative 1 to the second, and so forth. And you can do that. You're more than welcome to do all that in your head if you want to. So I'm just doing the arithmetic. I'm plugging in x to the function and see what happens. Okay? All right, well, this first one is going to be negative 4 squared. So that looks like that's going to be 16. The second one's going to be negative 2 squared. So that's going to be 4. And then 0 squared is 0. And then these things are going to kind of repeat themselves. So then you're going to have 4, and then you're going to have 16. Okay, so that's what's happening on that then. Okay, so what's going to happen with this is you'll see it, pretty clearly once you plot your points. So just go ahead and plot your points. Negative 2, 16, I'm just going to kind of put a dot way up there. Then I got negative 1, 4. And I still got 0, 0. Then I got 1, 4. And then I got 2, 16 way up like that. Okay, now look what happened on this problem. Okay, now we're talking horizontal, so what happened to the parabola? Which did it do? Shrink together or stretch out? It shrinks, so that what we call is a horizontal shrink. Okay, now you want to write that down, so we're kind of, as we're learning this, so that is called a horizontal shrink. Okay, now you probably want to write this down too. How about if I asked vertically? What if I'm asking vertically? I'm talking about y. Well, then what's happening to the red graph? Stretching. See how it's always going to be opposite. Okay, that's kind of a good thing to know. So if it horizontally shrinks, then it vertically stretches. Okay, either one is a correct answer to what that transformation is. Okay, so that's it. They're always going to be opposites. If it stretches one way, it shrinks the other way. right? Does that make sense? Okay, right? And let's see, with this one, you would have all real numbers is your domain, and then your range is 0 to infinity like that, okay? So you're going to kind of find is what the value of that number is, whether it's a number bigger than 1 or a fraction is going to be the difference, okay? Okay, let's do one more of these. We're going to try to keep the this one, and then we'll kind of start putting it all together here in just a minute. So that's kind of the challenge here. Okay, so absolute value of x. If you want to go ahead and get that graph, that would be your V shape that we've been doing. Okay, we'll get that. And once you learn the elementary functions, you'll be able to always graph them like real easy. So that would be absolute value of x. Okay, now this one, we're going to do just like we did the last problem. Now I think you need to scratch that off and make that a 1/2 x. I typed that wrong, it looks like. So scratch that out and make that y equals absolute value of 1x like that. Okay. Now, you don't have to write all these calculations down. If you feel like you need to, then you can do that. But what I'm going to do is just plug in the x values into the function and just kind of methodically do it one at a time. So I'm just kind of write down, I do a half times -2, I do a half times -1, and so forth. All right, we'll want to get those values like that. Okay, so the first one would be half of -2 is -1, but the absolute value of -1 is going to give 1. So you're taking half of the thing in absolute value, then taking the absolute value. The next one is going to be absolute value of -1/2, so that's a half. The next one is absolute value of 0. And then you're going to get the same thing over here. This is going to give a half. That's going to give 1 like that. Okay, so again, I'm doing arithmetic. I'm just plugging in to kind of crunch out those y's to see what happens. So if I plot my points now, I'll have -2, 1, -1/2, 0, 0, 1/2, and 2, 1 like that. And then we want to name the transformation. Okay, now we're talking horizontal. So you have the V shape. What happened to it? Did it stretch or did it shrink? It stretched, okay, that way. Okay, so we would say that this is a horizontal stretch. Okay, what if I asked you vertically? What would it be? It'd shrink, okay? It's always opposite. So if you name it one way, then it's going to, the other way is going to be the opposite, like that, okay? So that's how you know that. And you know that because of where that number is, okay? And the thing is, if you're graphing stuff, you can always go back to a table of values if you need to, and probably that's the best way to do these problems is like that. All right, so what you'd have is domain is all real numbers, of course, and the range is 0 to infinity like that. Okay, does everybody understand the arithmetic I did? Okay, all right, tell me thumbs up. I have no idea. Okay, we're kind of trying to do kind of a quick review and get some of this stuff down, but so on the next page, we're going to try to put it all together, okay? So I've kind of showed you all the main transformations you want to see. So what we're going to do, and I'm going to do this problem, and then this one I'm going to show you a couple of ways to do this. When you're doing a graph like this, and students always say, well, I just want to put it in my calculator. That's not the point. You're learning the math and how the math works. You want to understand the math behind this, okay? So here's kind of what you do. This problem right here has all kinds of transformations to it. The first thing, one thing it has is inside the squaring. Remember, that's left or right. So that thing right there that I'm highlighting in yellow is going to take this graph to the right 3. That's what that piece does right there. Okay. The other thing we have is this thing. Okay. That's going to do, it's going to multiply all the y values by 2. So that one's going to do a vertical stretch because things get bigger. Okay. And then this thing, the negative is going to reflect over x. Okay, and then finally this thing right there, that thing is going to do up 4. So as you're putting this all together, when your function has several transformations, you want to know which is which, okay? So it's going right 3, it's reflecting, it's stretching because the y values are getting doubled, and then everything goes up 4. Now, the other thing is the order you do these transformations make a difference, and you have to follow order of operations. So let me just kind of explain this to you right here. You don't need to write this down, but if you were doing an arithmetic problem, okay, in other words, if I was just plugging in something for x, say for instance I'm going to plug a 4 in there, okay? Now, how would you have to start that arithmetic problem? Where would you start? Parentheses. Inside the parentheses. So that means the first thing that you're going to do is left-right. See, that transformation is going left-right, so you're always going to start there, okay? So you're following order of operations when you do transformations. So then you would have 4 minus 2 times 1 to the second, okay? Then what would you do? When you do 1 to the second, you do the exponent. So you have 4 minus 2 like that, okay? And then what you would do is you would multiply. So see, you do the left-right first, you do the stretch shrink next, and then the last thing you always do is the up 4. So what you're doing, you don't have to memorize it, you need to understand that it's the same thing that order of operations does. You work in parentheses, then you get outside the parentheses, okay? So you kind of work with the x things first, and then the y things second, okay? So I'm going to show you kind of one way to do this, and like on a test and stuff, you're not required to do this table, but a lot of students seem to understand it this way, so I'm going to show you this way then. So first thing we're going to do is we're going to just plot the elementary function. Okay, so this one is a squaring function. So these are the points on the squaring function right here. And I think that last one where it says 2, 2, that needs to say 2, 4. Okay, those are the points that if you made a table of value for the squaring function, that's what you'd have. So what I want you to do is plot these points on the graph I gave you. And then that'll be the elementary function like that. Now, if you can do this in multiple steps, you can. What I like to have students do is just kind of do a table, because to me it helps you see how every piece goes. So we're going to, on this table I gave you, we're going to do this in order, kind of like this. So let me write down my function. So it's 4 minus 2 times, and then what was it, x minus 3 the second. Okay, so here's how you do this. Remember I said step 1 is left, right. Okay, so this part right here is going to do what? Right 3. Okay, so we're going to do that. Okay, that's how we're going to do that. Now, all you're going to do is in your mind, all of those x values are going to get bigger by 3. So take all of the x's and move them to the right 3. Okay, when you're doing the left, right stuff, you're changing the x values. So you just do this in your head, and what will happen in this first step is the y values are unchanged. So when I'm writing this down, I just know that, okay, step 1 does nothing with y. If you're taking things to the right 3, the y value is set. Okay? And then just kind of do this in your head. 2 plus 3 would be 5. 1 plus 3 would be 4. 0 plus 3 would be 3, and so forth. Okay? So we'll just kind of do that in your head. So 2 plus 3 is 5. 1 plus 3 is 4. 0 plus 3 is 3. Negative 1 plus 3 is 2. Negative 2 plus 3 is 1. Now you may be asking, why am I adding? Okay, because that clearly says subtracting. But what is the transformation? Right. If we're going right, all the x's get bigger. That's why. Don't be confused by that. Okay, we know that's right 3. That's why I'm making those x values get bigger by 3. Is that clear? If that was plus 3, then everything would go to the left. All your y's would get smaller. Okay, that's why I'm doing what I'm doing. So you got to understand that transformation. Okay, now that's step 1. Step 2 is going to be to do that thing, and just do it at the same time. This thing right here, that negative 2 is going to cause it to stretch vertically and reflect. So this is the way you can do this then. So you can just do it like this. You can just say multiply y by negative 2. Okay, like this, okay? So that's what that -2 is going to do. So the next thing you're going to do is all of these y values are going to get multiplied by -2. All the x values stay the same. So again, I'm just going to bring down the x values. The x's are now set from that first transformation like that, okay? Then in your head, just kind of multiply all by -2. 4 times -2 is -8. 1 times -2 is -2. 0 times -2 is 0. 1 times -2 is -2. 4 times -2 is -8. Okay? So what I've done so far is write 3. All the x's moved to the right. Now all those things got doubled. Now, you see how that's causing that to reflect? Because all the y's become negative, right? So that's making them change to the up down below the x-axis. Okay? And then the last thing that you do is that 4, see, you're adding 4, so that means everything is going to go up 4. Okay? So the last transformation, and you always do up-down stuff at the very end. Okay? So the last step would be to just basically make the y values, just add 4 to y, is what you're doing. Okay? The x values are set. That we took care of that in the first step. And we do that. Okay? So now I'm just going to take every y value in the previous step and make it get bigger by 4. So -8 plus 4 would be -4. -2 plus 4 would be 2. 0 plus 4 would be 4. -2 plus 4 is 2. -8 plus 4 is -4. So that's actually how those points get transformed, and it's order of operations. Now here's what would happen, guys. If you just took, like, if you did plug -2 right there, if you plugged it in there, you would get that y value. But that's showing you how things transform, okay? Are you guys following what I'm doing? You don't have to do it this way, but some students kind of, to me, it's an easy way to keep track of it. If you know how these transformations work, you can just do all of that in your head and move those 5 points. Okay, with a little practice, you can do that. So now what I want you to do is just plot those points that we got. So go to your graph and do that last column and plot those out. So we have 1, -4. We have 2, 2. Whoops, not that. Come on. So 2, 2. Then we have 3, 4. And 4, 2. And 5, -4. Okay, so what I'm kind of wanting you all to see when you get that plotted is you want to see if everything happened the way we thought it would. Okay, did my parabola go to the right 3? Look at this point right here. That point went to the right 3, didn't it? Did it go up 4? Yeah. Did it reflect? Clearly. Okay. And did it kind of, is it a little bit stretched? It's a little hard to see on that, but it did stretch. Okay, like that. So it did everything you do, and so you can do it that way. The benefit of doing this way is you can keep track of everything, and you can learn and understand how those transformations work. But like on a test or something, all I would have you do is just, without a calculator too, is just graph the elementary function and graph the final thing. You can either do that in your head, or you can methodically do it like that. Okay, those are your choices. Okay, is everybody with me? Yeah.
For the right 3, I mean, is it safe to say that if it's inside the function that you take the opposite?
Yes.
Okay.
See, you're saying exactly what I want a student to say. If you're inside the function, x's get changed. And it's kind of opposite of what you would think. Okay? If you're outside the function, it's y's that get changed, and it is the way you would think. Okay? So that's kind of a good way to begin to put that together. Okay? Okay. Okay, so let's do a few more of these things and kind of put these together as we go. So this one right here, first of all, the first thing that you want to do is you want to know what your transformations are. Okay? So let's see. Tell me what the +4 does. That goes up 4. How do you know? Because it's outside of the function and it's making y get bigger. So that's up 4. Okay, how about the -2? Just all in one step, what does that do? It reflects it over x, and what else? It makes the y values bigger, so it stretches. So that right there would be, we would say reflect over the x-axis, and then we would say that it's a vertical stretch, like that. Okay, now when you're learning how to do these things, you have to do order of operations. You got to do this in the right order. So what I'm going to do on this is, I've already given you the x values I'm going to use. Now we're doing an absolute value of x. So if you do absolute value of x, then these points become this. That would be absolute value. You're just doing absolute value of x. So these would be those are going to be the basic points that we're going to change. Okay. Now what you got to think about is you got to think about what order would we do this in. So we know we're up 4, we know we reflect, and we vertically stretch. So think about order of operations. If you plugged in a number for x, what would you do first? Would you multiply by -2 or add 4? You'd multiply by -2. You multiply before you add. So you're following order of operations. So what I would do on my chart is I would just say multiply y by -2. And then the second thing we're going to do is we're going to go up 4. Okay, like that. And you're just going to transform those points in 2 steps, and then you'll have it. Okay? So I'm going to start by, you can go ahead and plot your basic points if you want to. So this is the absolute value. So we got -2, 2, -1, 1, 0, 0, and so forth. Okay, we're going to do that in a dashed line like that. Okay, so you want to just do this in your head. In step 1, the x's, you're not doing anything to x, you're multiplying y by 2 because that -2 is outside of the function. Okay, just do that in your head. 2 times -2 is -4. 1 times -2 is -2. 0 times 2 is 0. 1 times -2 is -2. 2 times -2 is -4. Now, you don't want to plot those points. Yeah, okay, If the
2 is positive, would it be reflected over the y?
You have to talk a little bit louder if you're way back there because I can't hear.
If the 2 is positive, would it be reflected over the y-axis? How do you determine what?
Oh, okay, if that was a positive 2,
Yeah.
then nothing would change. Okay, the y values would still be the same. They would still be positive, so it wouldn't change.
Okay.
When you multiply a y by negative, then it changes, okay? It reflects like that. That's why, okay?
Yeah.
All right, so now we just take everything up 4. So in this step, take all those y values that I got highlighted in yellow and just add 4 to it, make them get bigger. And then we'll have the final result like that. So you would have -4 plus 4 is 0. And let's see, -2 plus 4 is 2. 0 plus 4 is 4. -2 plus 4 is 2. And -4 plus 4 is 0. Okay, I think I got everything right. Okay, I'm just adding 4 to all those y values. Okay, all right, plot it and let's see what it looks like. So it looks like I have -2, 0. -1, 2, 0, 4, 1, 2, 2, 0. So there's your final thing. Okay? Now what did we do? We reflected over the x-axis. Clearly you can tell it's upside down. Does it look like it's stretched, kind of, this way? Does it look like it's stretched? Okay. Did it, and let's see, clearly everything moved up 4. Okay, so that's how that goes. Okay, now you can do these things this way if you want to, and just kind of organize it in that format, and it makes it a little bit easier to do. Okay, all right, any questions? Okay, now before I finish up here, I'm not gonna do the next example. We'll kind of finish this up next time, but I do want to show you something on the internet, and I will post these things on Canvas, so some of you, it might help you a little bit on this. I was going to just show you this thing right here. And this is what we're ultimately trying to learn here anyway today, is, let me take this. This is a square root function, okay, kind of like this. So let's kind of look at what happens when you transfer things. This is what we're trying to do, is kind of put it all together. So x minus under the radical. What does this part right here do? Just that part. Left, right. Okay, all right. So what will happen on this, and so if I give you this link, you can play with it a little bit, and it might help some of you there. So basically the idea would be if I, whoops, not that one. I don't know which one it is. Yeah, okay, it's hard to get these things back to where they are. It won't stop where I want it to. And let me try this. No, it's not that one. Not that, there we go, okay, like that. So notice what's happening, okay? I got x minus 3.3. So see it moved to the right 3.3. Okay, if I go this way, that's kind of up and down. That's doing up and down. So notice on the up and down, what's happening on this is the y value out here is changing, okay, like that. So you can kind of play with these sliders on this, and it kind of shows you how this stuff goes. So I'm going to post this thing, and then you can kind of play with it. And because what it does is it shows the transformation, and it shows how the numbers change. I think that would be very helpful for some of you if you don't have a good background for this. What do you think? What's that?
Desmos?
Desmos has really good things. I use GeoGebra and Desmos quite a bit.
Yeah.
Have a lot of you used Desmos like in high school and stuff? GeoGebra is good. So I'm going to start posting these kind of on Canvas. And you can play with them a little bit, and I think it would really help you to kind of see how these things go. Okay? All right, that'll wrap us up. So 2 weeks down, and we've already done 5 sections. You see what I mean? Okay? I feel like I'm going slow, but it just kind of depends. Depends on you. Okay, so have a good weekend.